let's discuss how to implement the load byte unsigned instruction in the MIPS architecture. Like all of the other loads and stores, the address for this instruction is calculated by an address, which is a base calculated from R of RS plus an offset. So we have assigned immediate that we're going to add to this. So this is our base plus offset. So in the encoding, we have our base registers calculated here. So this is our base register, which is indicated by RS. We have our immediate value here, which is our offset. And then we need to figure out where we're going to take the data from the data memory and put that into the register file. So which register we put this data in is indicated by register 5. So this is our data destination, and this is our register RT. So to calculate the address, we want to find R of RS. So here RS is the value 4, and the contents of RS will come out right in front of the ALU. To calculate the offset, we're going to take our immediate value and feed it through the ALU source 2 mux, which will have to have the value 1, and we will now have our sign extended immediate coming into our ALU. Then we will send the calculated address out to our data memory by setting the ALU up to add. Now, there's one particular caveat we need to worry about for load byte that we don't have to worry about for load word. In this case, we can have a value in our register 4 that is not word aligned. So let's say, for example, we have that value hex 3 inside of our register. In this circumstance, we need to make sure that the access of that value is still going to be word aligned. So what we want to do is we're going to take just the most significant bits from this address, and we're going to chop off the last 2 bits and replace them with zeros when we're doing our word access. So what we're going to do is we're going to take bits 31 down to 2, and we're going to append 2 bits of 0 after this so that our address is word aligned. And we're going to scuttle off the last 2 bytes, bits 1 down to 0, and we're going to save those for later to figure out which byte of the word we want to access. So we're going to set our word right enabled to 0, our byte right enabled to 0, and we don't really care what's going into the data in. Okay, now that we've set our address to be the value we want, we need to figure out what information we want. So out of this data out is going to come a 32-bit signal. And before, with the load word instruction, we showed that we would be able to overwrite our instruction with a load here. So we're doing a load. If this is set to 1, we're going to do a load and bypass the ALU and send that to our destination register. And our destination register in this case would be indicated by RT, which is register 5. And we would set our write enable to 1 and our RD source to 1 to select RT. Now the next part's a little bit complicated, so we're going to chop this up into a couple different segments. We're going to take bits 31 down to bits 24 on 1. We're going to take bits 23 down to bits 16. We're going to take bits 15 down to bits 8, and bits 7 down to 0 as the 4 different words that we can extract from this message, from this word. And we're going to use a multiplexer to choose which one of these bytes we actually want from this address, and we're going to set them to 0, 1, 2, and 3 respectively, and we're going to use the 2 bits of address that we saved as the control inputs for our multiplexer. So for example here we want 1, 1 as our bits, and so it will select the 3 most significant bits, 31 down to 24, as the bits that come out. So then we're going to take those 8 bits, so this is an 8-bit signal, and we're going to append 24 bits of zeros to the front of it so that it becomes a 32-bit signal again. Then we need to choose between our original 32-bit signal and our byte. So we're going to use another multiplexer here, where 0 is for a regular load word, 1 is for load byte, and we're going to have a new signal load byte that will control this mux to indicate that we want an 8-bit byte rather than the 32-bit word.